All right, we're redoing some cubics, so factoring the sum and difference of cubes. So I'm just throwing this out. We've already done these notes. What should set off the idea that it might be a sum or difference of cubes is you're looking at the first and the last terms. There's only two terms, and they're both cubic. Obviously, sum is addition, difference is subtraction. So there's only going to be two terms. This SOAP method is our shortcut. And do you remember what SOAP stood for and what it does for us? Same, opposite, and then always positive. Yep. And it sets up your signs. Your first sign is the same as what you started with. The second sign will be the opposite, and the last one's always positive. And the idea being you're going to have a binomial and a trinomial. So if you're doing a difference of squares, I normally set my signs first with SOAP. So just throwing that down there, if I had a to the third minus b to the third, I'm going to break my signs up like this. Now, I'm not putting that in there yet. Now, do you remember how to deal with this binomial and trinomial? So same sign, the opposite, and then always positive. Do you remember how we placed these numbers and where we found them? So what do I do to get this first set? I'm going to take the cube root. So the cube root of a to the third is a, meaning what times itself? 3 times. A times a times a. And then the cube root of b to the third. So my habit is to put my signs in first, then go back and take my cube roots and drop them there, and then I build off of that. How do I get into here now? Okay. So this a times a squared is going to give me back my a to the third. So I square the first term and I drop it here. I took the cube root. So one of them is here and then two are here. I'm going to take the last term and square it, put it here. So b times b to the second is b to the third. What do I put in the middle? Okay, it is the product of the roots. This is going to be the same thing, but we're going to have different signs. So again, this is my pattern. You can do whatever you want, but this is a shortcut. It's a pattern. You know it or you don't know it. And it's always bad when you have 2 or 3 of these on a test, because this was the new factoring learned in this chapter, and you get them all wrong because you didn't remember it. It's just like memorizing a formula to plug in. So same sign, opposite, always positive. I know it's cubic because there's only 2 terms and there's powers of 3. Cube roots drop here, and then I build off of that. I square the a, I square the b, and the middle is the product. And this is the one time you ignore your signs. Got it? The signs were set. All right, so no matter what I'm giving you, the first thing you should always do is look for a GCF. Now, I don't believe there's a GCF here. Yeah, there's no GCF here, but I double checked it. What stands out to me is there's 2 terms and that power of 3. So the next thing I'm going to do is check, is 216 a cubic number? And we're not as familiar with those. So how do you put it in your calculator to check? Do you remember? Type in the 3 because that's the root we're defining. Second, and your power key, which is your any root key is what we're going for. So it doesn't matter which calculator you have. This is the process. Now in mine, I have that thing that says x. It has to be there. So you're saying the 3 is the x root, so the cube root. And the multi-views, it pops it up as little power. So the cube root of 216 is 6. All right, then check the other. Sorry, thank you. So I could just go back up and change it, or I could go through put in the 3, then the x root, oopsie daisies, 3 x root of what? 343, and that is 7. So they're both cubic numbers. If you put this in your calculator, what are you doing? You're taking 3 times the square root of 125, which is some kind of crazy number. Okay? Well, 125 is a cubic number, so I just picked it. But the idea is this is 3 times the square root. In order to do it correctly, you need to see that little x there because you're defining it. Okay? I just picked a random number to show that it was wrong. Okay. So now that I know that this is definitely all cubics, I'm going to jump into building it. So here's my SOAP. And honestly, these should be free points on a test. You don't have to try to figure out math. You just need to know it. So same sign, opposite, always positive. That's it. Set your signs up. And then, like I said, my goal is I set my signs and I have a method that I always do the same when I'm teaching it. I'm going to take the cube roots and drop them here. We already know that's 6 with an x, and we know this is 7. What should be my first number here in the trinomial? This is where you think. Use those brains. You have to square the whole term. So if you square the 6, it'd be 36x squared. And I'm glad you brought that up, because that's one of the big mistakes is you're thinking square it, but a lot of people only square the variable. Now, if you think about this, if I did put just a 6 in here, would 6 times 6 give me back my 216? No. So 6 times 36, there's my 216. I have one piece here. I need the other two here when you're thinking about that power of 3. Okay, the last term is going to be 49 because you took 7 and you squared it. So 7 times the 49 will give you back my 343. In the middle term, I'm gonna multiply these. So 6x times 7, it's the product. This one is the product, so it'd be 42x. So it does come from here. So you just sort of smash them together is the term I was saying. It's in the middle, you smash them together, but you do have to remember that's multiplication. So that's the product. All right, that's it. And I know I have extra scribble and scratch on here, but this right here is my answer. I just smeared it. That's my answer. Now let's talk about a couple things, even though I just made it really bad. This won't factor any further, but if it was something like x squared minus 9, it would be a difference of squares. This looks like a perfect square, so I want to talk about this. So you don't have to write this down. I'm just going to erase it. This looks like a perfect square. It looks like I should factor it to be 6x plus 7 and 6x plus 7. Doesn't that look like what I should do? Do we agree? Okay. The 6x times 6x is 36x squared. The 7 times 7 is 49. The problem is the outside is 42x, and so is the inside, which makes it what, 84x? And that's not what I have. So for us, this quadratic trinomial will not factor as a perfect square because it doesn't work to give us the right middle term. But it looks like one, doesn't it? Okay, now, above and beyond what we're doing, if this was a quartic trinomial, power 4 here and a power 2 here and a constant, it would factor. Quartic trinomials do factor, but that is above and beyond our Algebra 2 math. Got it? Okay, so if you haven't already started the next one, even though I was hoping you'd wait for me, what are we looking at here? I have two terms. It's a plus sign. But yeah, is there a GCF? I don't believe so. Am I right or wrong? No GCF? 8. Yeah, there is not a GCF. Yeah, there's not a GCF. 27 only divides by 27, 9, and 3, and this doesn't divide by 3, so it's not going to divide by 9 or 27. It doesn't work with the smallest factor. Okay, 27 is cubic. 3 times 3 times 3. 512 is cubic. Does anyone know what it is? What's the cube root of 512? Then use your calculators. But we should practice putting it in. It's 8. At least you're using it at home, right? The cube. I was trying to figure out how to make a square. Oh, I gotcha. 512, the cube root of that is 8. But what about this x to the 6? How are we going to deal with that? I'm going to start with my cubic because the numbers are cubic. So same sign, opposite, always positive. So same as plus, opposite, always positive. Cube root of 27 is 3. Cube root of 512 is 8. But what about this x to the 6? What's the cube root of x to the 6? What times itself 3 times is going to give me that? What is the cube root of x to the 6? So think about what times 3 times? What times itself 3 times? It is going to be x squared. Well, think about this. If you do x times x times x, that's x to the 3rd, right? But if I put x squared, x squared, x squared, there's 2, 4, and 6 of them. Remember, when you multiply the bases, you add the powers. Essentially, when you take the cube root of a power, you're dividing it by 3. We're going to get into that in chapter 8. If you think about this, take x to the third, take the 3 divided by 3, and you get x to the first. So the number is the cube root, but the power you divide. It's just like when you multiply, you add them. Nope, you have to add them. Yeah, if you have a power to power, that's when you multiply them. Okay, what goes here? What comes back? What do I need? 3x squared times what to get me back to 27x to the 6th? 9x to the 4th. So you have to remember to actually square the number 3 times 3 and then add those powers, which those powers add up to 6. Okay, what goes last? You said what? 64. And what goes in this middle? What gets smashed together? You would take 3x squared times 8. So did you say 24x squared? There you go. Now, we're not factoring this further, okay? But you should check the binomial part. All right, last one. I'll let you do it real quick, and then we'll do it together. And I think there's one basic thing I want to show you real quick. Bless you. Bless you. Oh, that's not an 8 there. You didn't do the same thing with it. So I'm going into, this is cubic, 100% cubic. Now, isn't 64 also a square number? 8 times 8, 64. So I'm basing my decision that it's cubic on the powers and the 125. But this is also a perfect square. So the cube, same, opposite, always positive. The cube root of 125 is 5. Keep 1z. The cube root of 64, x to the third, is 4x. So we're just bringing the variables down. Take this and square it. You should have a 25, but z squared. Take this and square it. What should I get for my last term? What should I get for my last? 16, bless you, x squared. What goes in the middle? Yep, 20zx or 20xz. It's totally up to you. There you go. That's it. Okay? Now, last thing. I gave you this one, and I already factored it for you. Okay? So SOAP, set it up. What I want to show you, and just remind you, if I would reverse this, so section 6.2, we took something like this and got an answer. That's what I want to show you. If we went back and we distributed this x to all 3 pieces, right, using our old skills of distributing, we would have x to the third, we would have a positive 2x squared, and then we would have a positive 4x. Then I'm going to come back and distribute my negative 2. So negative 2x squared, negative 4x, and a negative 8. When I go to add like terms, the highest power is x to the third. Remember, we want it in standard form? When I go to add the x squareds, you notice that they cancel out. Positive 2 and negative 2. And when I go to add the x's, they cancel out. And what's left? Do you see that this really does factor and give us right back to the answer? Just like if you factor with reverse FOIL and then you FOIL it, you get back to the answer. So I don't need to double check, but it is true. Everything between the first and the last terms cancel out. That's how you could double check to see if you're doing it right. Okay? Last thing I want to talk about, and it comes up on the worksheet. So on your one worksheet, it's number 18. So I'm just going to put this here. But it looks, you know what, I'm just going to pull the worksheet. I just want to bring it up. I brought it up in my other video. If I have this, and I am on 6.4 factoring practice by concepts, so it should be the next page in your packet, and I jump to number 18, I can factor this as it is. There is a GCF of 3n, which leaves me 8 minus 27x to the third. So I can factor it like this. We just did one like this, right? Where there was a variable on the second part also. But let's say I want to rearrange it. Let's say I don't want to factor it like that. And I rearranged it to negative 81n x to the third plus 24n. And a lot of times we do this, right? Because we want that power up front. And so then I factor out not just a 3n, but a negative 3n. And there's a reason for that. this should be what? 27x to the third minus 8. You cannot use SOAP with a negative leading coefficient. So if this was negative, and I feel like that's really hard to read, if that was negative, that would cause us a problem. I don't know that that's any better. So anytime your leading coefficient is negative, you need to factor out the negative, because if you think about the acronym SOAP, we're setting the signs based off the middle sign. You cannot have a negative sign out front. So you could factor it in this form. And if you do that, you'd be doing same, opposite, always positive. So cube root, square it, 4, square it, 9x squared, and the middle is the product of 6x. If I factor this, and I leave my negative 3n out there, and I use SOAP, same, opposite, always positive, the cube root is 3x, the cube root is 2. I square it, 9x squared, I square it 4, and the middle is 6x. Take a minute and look at these. The only difference is that the negative sign's out front, but not here. If I would put the negative sign in, do you see that would flip this to make it a negative 3x and a negative 2? So if we distribute, negative 3x and a positive 2. So do you see that these are just the opposite signs because these are the opposite? And then it's in a different order, but there's a positive 4, a 6x, and a 9x squared. Both these answers acceptable. So you could leave it out of order and factor it, but if you rearrange it or ever have a leading coefficient negative, you have to take it out to use the shortcut. Are we clear on that? Okay.